Hello, this is the second complex numbers video of OCR Pure Core AS for Mathematics, and the title is Adding and Subtracting Complex Numbers. Obviously, if we have a number system, we need it to be able to carry out operations such as addition and subtraction. Let's consider what I mean by a number system. In earlier days of numeracy, we just dealt with the counting numbers. When we then added zero and negative numbers, then we dealt with integers. We then added fractions and decimals or rational numbers. And then when we added the irrational numbers, sometimes denoted by the symbol p, that gave us the real number system. And those are all the numbers we've been dealing with to date. By adding the square root of -1, we now have a number system that is called the complex number system, and it encompasses all the other numbers we've dealt with in our maths so far. So, given that we know that the square root of -1 has been defined as I, let's have a look at the square root of -16. Remembering that the square root symbol means that we take the positive square root. We may also remember from work done previously in GCSE that the square root of AB can be written as the square root of A times the square root of B. Therefore, we can write the square root of -16 as being the square root of 16 times the square root of -1, or in other words, as 4i. Similarly, for the square root of -20, we can write that the square root of -20 is the square root of 4 times the square root of 5 times the square root of -1, which will give us 2 root 5i. Numbers such as z equals 2 plus 4i are called complex numbers, and in general we have that z is denoted by a plus bi, where both a and b are real numbers. They could also be 0, which would mean that complex numbers can be entirely real or imaginary, or have both real and imaginary parts. Let's consider the following calculation. You may wish to pause to work out how to do this for yourself. It's actually just like algebra. So we sum the elements that are alike, in this case the real or the imaginary, to get a resulting complex number answer. In other words, we have for the real part 2 plus 4, and then we also have 4i minus I, being careful with signs for the imaginary part, which would give us 6 plus 3i as the complex sum. When you are working with brackets, it's very important to be careful about the signs. Subtraction works in the same way as addition, in that you subtract like elements. So here, for example, you would think that it was going to be 4 minus 3 for the real elements, and then again, being careful with signs, minus 2i minus 5i for the imaginary elements, which gives 1 minus 7i as the complex answer. So do be aware of the double negatives when subtracting, and take care collecting the like terms together. In this context, of course, the like terms are real parts and imaginary parts. Always give your answers in the form a plus or minus bi, where a and b are real numbers. In the next session, 1.3, we will look at multiplying complex numbers.